Good morning, everyone. Dear authors and invited guests, welcome to the technical session 8B. Myself, Aarti Mohan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the Third World Conference on Information Systems for Business Management, ISBM 2024, Bangkok, Thailand. The third edition of the conference is being organized in a hybrid mode. The physical event is being organized today in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 12th and 13th September 2024. I hope you all will be enjoying this knowledgeable and interactive session throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answer session round. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants to stay connected till the closing remarks. If you have any sort of query or any update, you can write it to me in the chat box. Just before we get started, I would like you all to introduce you to the session chair who would be chairing the session, Dr. Geetanjali R. Shinde. We welcome you, ma'am.
Thank you.
Dr. Geetanjali R. Shinde has overall 15 years of teaching experience. She is presently working as assistant professor in Department of Computer Engineering at Vishwakarma Institute of Information Technology, Pune, India. She has presented a research article in World Wireless Research Forum meeting, Beijing, China. She has published 50 plus papers in national and international conferences and journals. She is the author and editor of 10 plus books. Ma'am, it's a great pleasure to have you on board with us.
Thank you. Thank you, Adi.
Moving on to our first presentation, I would like to call upon the paper title, Breaking Down Barriers, Investigating the Advantages and Challenges of Open RAN Deployment in Next Generation Wireless Network. Dear presenter, could you please start with your presentation? Moving on to the next presentation, I guess the person is not here. Emotion recognition in Gujarati audio using feature extraction for machine learning models. Dear presenter, could you please start with the presentation? Moving on to our next presentation, we have Ensemble System for Cybersecurity Threat Detection. Dear presenter, could you please start with your presentation?
Yes, so as I was saying, ensemble learning is a technique that combines multiple machine learning models to improve its performance. The benefits of ensemble learning include reducing the risk errors associated with each individual model, as each individual model has a limitation. If we combine different models, it reduces the risks of these errors. And it also enhances the accuracy of each model as well. It's also ensemble learning is also used in various domains, including finance, healthcare, and in our case, for cybersecurity to detect anomalies and prevent attacks. So our proposed system includes 5 machine learning algorithms. The first algorithm is the random forest. It uses decision trees and it's best for handling noisy data. And then XGBoost is a gradient boosting method and it works well with nonlinear data patterns. We also use SVM, support vector machine, which creates decision boundaries for classification, and it's efficient in high dimensional spaces. And then we have neural networks, which simulates the brain neuron functioning, and it learns complex patterns from data. Deep neural networks is an advanced version of neural networks with multiple layers. Our ensemble machine learning algorithm uses a meta classifier for final decision making, meaning that it depends on majority voting from all five. So our data set goes through all five algorithms and takes majority voting. For the literature review, we have multiple previous researchers that have used all of the five machine learning algorithms. So random forest was used in two researches, and it was proven effective for network anomaly detection due to its ability to handle high dimensional data while maintaining accuracy. XGBoost was used for IoT malware detection in previous research. SVM was used in identification for intrusion detection in previous research. Neural networks were capable of learning and identifying complex patterns in data, also in two research papers. Deep neural networks were used in in pattern recognition for cybersecurity. And how this is all relevant to our current study. Our current study addresses all of these issues and works on evolving all of these five machine learning algorithms to improve their accuracy. So for data collection, we used the KDD COP99 dataset, which is recognized in cybersecurity for benchmarking intrusion detection systems. We train our model. So as I said, we use each individual classifier alone with the same data set. And then the model is created by aggregating the predictions of each base classifier using majority voting based on the outputs of the five different algorithms. And of course, our dataset was split into training and testing sets, and cross-validation was used to ensure the robustness and mitigate the impact of the data split on the model performance. So we evaluate our model using these four evaluation metrics. We have accuracy, which is the proportion of correctly predicted instances among all total predictions. We have the precision, which is the ratio of true positive predictions to the sum of true positive and false positive prediction. Whereas recall or sensitivity is the ratio of true positive predictions to the sum of true positive and false negative. And then we have the F1 score, which is the mean of both precision and recall. Here we have the results of our paper and our methodology. So our model achieved the highest accuracy at 98.7%. It outperformed each individual classifier of all five, and it demonstrated particularly strong performance in recall. So here in this table, we have all five. We have the decision tree, which is random forest, SVM. We have the k-nearest neighbors, logistic regression, and then our ensemble model. So our ensemble model scored the highest in each of the four evaluation metrics. So in comparison, the individual classifiers, as effective as they are, they still have some weaknesses. Our ensemble model showed higher accuracy and robustness in all the evaluation metrics. So our insights is that combining diverse models mitigates individual weaknesses, leading to a more balanced and reliable system. And our approach involves and improves overall detection rates for real-world cybersecurity applications. So in conclusion, our system, it enhances cybersecurity threat detection. It outperforms traditional single machine learning algorithms, and it's demonstrated potential for real-world application. So for optimization for future work, we want to explore hyperparameters tuning of individual classifiers within the ensemble method for further performance gains. For expansions, we want to incorporate additional classifiers such as KNN and logistic regression. to diversify our method. And for real-world implementation, we want to test the model in real-time cybersecurity environments to validate its practical effectiveness. Here we have our references for our paper. And that is it for my presentation.
Nice presentation, Sarah.
Thank
I
you so
just like to know about, you have explained that is Ensemble is working better than other single models. So can you explain that is from which features from your data set having more impact on result? So explain more about your data set.
About our data set. So we tried
Yes,
our
please.
code with multiple data sets, and we used the different data sets from Kaggle at first. It was IoT intrusion detection and malicious code detection. And we tried our code on 5 different data sets. And the scores that I presented in the results were the average from all data sets, like
Okay.
all testings.
Okay, and my suggestion would be that is, yes, ensemble learning is already proved that instead of single models, you should always go for ensemble. So
Mhm.
comparison should be that is some of the researchers they have already used ensemble model using some different 3-4 models. So what result they have achieved, and then compare your results with them instead of comparing with single, because ensemble learning already it is proved that it is better always than single models. So you should
Okay,
go for that. Nice presentation. Thank you.
thank you.
Thank you so much for your presentation. Thank you, ma'am. Moving on to our next presentation. We have factors influencing online impulsive buying behavior, the case of fashion industry in Indonesia. Dear presenter, could you please start with your presentation?
Okay, thank you very much for the opportunity. Let me try to share my screen first. Can everyone see my screen?
Yes, it's visible. Yep.
Okay, I will start my presentation then. A very good morning to everyone. I am going to present my paper together with Eugene Nathanael, who's actually also here, so he will be able to also help with the questions later on. Our paper is entitled Factors Influencing Online Impulsive Buying Behavior in the Case of Fashion Industry in Indonesia and from Venus University. So this is the research background. As we all know, the Indonesia's economy is currently growing, and there's an affluent population, which makes it a prime market for impulse buying. We have a 5% annual economic growth, and then most of the populations are active users of social media, and 72.5% of Indonesian social media users make impulsive purchases online. And Indonesia also ranks third in the world for social media users with 191.4 million residents. And we use basically almost all of the social media there is, yeah, mainly WhatsApp, Facebook, Instagram, YouTube, as well as TikTok. And then we would like to focus on the fashion industry because it contributed 18% to the creative economy. And these are some of the brands. I'm pretty sure it's not only famous in Indonesia, but also all across the world. We have Uniqlo, H&M, Zara, Levi's, Nike, Adidas, and so on. And then we also have some of the traditional segment, which is more specialized in the Indonesian market, which are Aiger, Zoya, and Al Hijab, yeah, because most of the populations in Indonesia are Muslim, so we also have hijab fashion. And for the top 3 Indonesian consumer, they purchase mostly clothing, shoes, as well as electronics. So this is our research problem. This study is going to examine the impulse buying in Indonesia, focusing on social media's impact on consumers. And then fashion brands in Indonesia, they try to incite what we call as FOMO. FOMO is fear of missing out, which increases the likelihood of impulsive purchases. So basically, what we are trying to say is that sometimes people don't really need to buy the clothes and the purchases that they made, but because they feel that they're missing out on the trend, that is why they're buying all of these products, and that's what we also call it impulse buying. And we have 3 research questions. Is impulsive buying behavior common in online channels? Which factors encourage and discourage online buying behavior? And does social media use influence impulsive buying behavior? All of these 3 research questions will be discussed later in the discussion and the conclusion. So at our proposed model, we distributed online questionnaires to respondents between the age of 18 to 35 years old who live in urban areas in Indonesia and frequently use social media. We collected 120 responses, and the questionnaire was designed into 4 different parts using 7-point Likert scale, both in English and Indonesian. So we did a pre-test and also pilot test to ensure the validity and reliability of our questionnaire items, and then we tested the hypothesis using multiple regression in SPSS. So these are the 6 hypotheses, which are, as you can see from the model, represents the relationship between the independent variables and the dependent variable. So the independent variables are advanced marketing techniques, use of credit cards, easy access and convenience, and ability to activate the 5 senses, shipping and refund costs, as well as social media use. This is the result of our reliability test using Compass Alpha. As you can see, for all constructs, we received the conclusion that it's reliable because the Compass Alpha are all above 0.6. And this is for the validity test, and as we can see as well, all of the significance are below 0.05, which means that they're all valid. And now for the R-square, we got around 0.26 R-square, which means it accounts for more or less 26% of the variation in the dependent variable. And then we also conducted the multi-collinearity test, and as you can see, there is no values above 0.7, which means that there is no multi-collinearity issue with the data. For the F-test, as we can see from the significance, it's well below 0.05, which means that the whole model is very much significant. And then for the t-test, here, these are each of the independent variables, and these are the p-values. Those with p-values below 0.05 shows that there's a significant effect, while those with p-values above that, then there is no significant effect. And then here from the coefficient, we can also see the relationship. As you can see for IAFS and SRC, both of them have negative effect on impulsive buying behavior. So based on those results, these are the findings of our research. For advanced marketing techniques, use of credit cards, easy access and convenience, shipping and refund costs, they are all supported. However, for the inability to activate the 5 senses and social media use, these are not supported in contrary to the original findings. So this is the discussion. As I mentioned, we will be answering the research question in the beginning. The first research question was, is impulsive buying behavior common in online channels? And we can actually answer that with the descriptive statistics. The average of all items in the descriptive statistics of the impulsive buying behavior were about 4. And the midpoint of 7-point Likert scale is a 4. So it means that they actually tend to do impulsive buying behavior. They actually show that their buying behavior is impulsive, especially on online channels. And the majority of the younger individuals between the age of 18 to 24 are more susceptible to impulsive buying behavior, and mainly women and those with lower income. This is based on a previous research by Kapoor et al. 2020, which supported the results of our study. And now for the second research question, which factors encourage and discourage online buying behavior? As we can see from the coefficient, these 4 advanced marketing techniques, use of credit cards, easy access and convenience, and social media use have positive coefficient, which means they are encouraging impulsive buying behavior. As you can see, if you're able to use your credit card, it's easy for you to access and it's also convenient. Then of course, then it will increase the chance of you're actually going to make an impulsive buying decision. And then for inability to activate the 5 senses, and shipping and refund costs. That is also obviously discouraging because of the negative coefficient, but also logically because if you have shipping and refund costs, then normally you don't really want to purchase online because then you need to bear this cost in case of in case that you want a refund or in case that you ordered from a place that is far away, then therefore your shipping cost will increase as well. And then for the last research question, does social media use influence impulsive buying behavior? Since the p-value is more than 0.05, it shows that it actually is not significant. So this is also a very interesting conclusion that we got. However, there is another study conducted by Sangeeta and Maria Pan back in 2023 last year, who also proved that their hypothesis that there is no significant impact of social media factors on impulsive buying behavior to be true. So there was already a previous research conducted in a different country who had the same result. So these are several of the managerial implications or the practical implications. This is basically based on our descriptive statistics results. So fashion brands should optimize their online channels since it has been proven that impulsive buying behavior is common on online channels as our conclusion for research question one just now. So they can use AI, data analytics to tailor advertisement, product suggestion, website design, and so on, so that they are even more intrigued to purchase impulsively. And it can also include interactive product comparison, survey quizzes to promote and explore, these behaviors of unanticipated purchases. So basically, even though they didn't plan to buy our products, we can actually use all of these online mechanism to make them feel like they want to purchase our product. And then we can also utilize influencer partnership and live streaming platforms to highlight products in real time. And then fashion brands should also carry out offline channels still, since it has been proven that most of the respondents show both on online and offline channels. So based on our descriptive statistics, our respondents actually show both, not just on online channel, but also offline channel. That's why the integration between the two, or maybe what we call as omni-channel, is quite important. We can use interactive display, instant digital experiences, and then we can include several loyalty programs that is applicable across channels. So for example, consumers can earn loyalty rewards for both online and offline channel, and they can offer incentives on one channel that can be redeemed in another. For example, you can have an online voucher that you can redeem if you make purchases on site. Sorry. Okay, now these are the implication based on our hypothesis testing results. As we have seen before, advanced marketing technique has a significant impact. Therefore, it's important to emphasize that there's limited numbers of products available. There's a countdown timer so that they purchase during that short time period. You can also have exclusive offers only for specific group of customers, and so on. These are all marketing techniques that are used to induce impulsive buying behavior. And also we can use emotional storytelling and visual impact to establish a stronger connection with the customer, such as using client testimonials, which are quite common in the online channels. And then, as I also mentioned, that the use of credit card had a significant impact. So therefore, it's important for the brands to offer this kind of financing options. It can be installment plans, can be buy now, pay later schemes, which is very much rising at the moment, especially in Indonesia. And then we can also do reward point programs for the credit cards. So this will make expensive products more accessible, and it encourages more spending and obviously more impulsive buying behavior. And then because we also have the discouraging factors just now, which were shipping and refund costs, that was proven to be significant as well. So we also encourage the sellers to offer free or expedited shipping options to remove potential barriers. to impulsive purchases and also give refunds for products that have arrived, what are either damaged or lost, or maybe it was the wrong shipment, and so on, so that the customers do not feel that there's any financial risk in the shipping process. And by eliminating the discouraging factor, then we will actually arrive at a more impulsive buying behavior for the customers. So these are the limitations and recommendations of our study. The limitations will be because the target respondents were only between 18 to 35 years old, so it might not be suitable for businesses that target a different age group, especially those who target an older generation. And then the respondents were strictly from Indonesia, so other countries might require a different marketing strategy depending on their market. And also the study was only carried out in the fashion industry, so it might not be suitable for businesses in other sectors of the market. Several of the recommendations for future research is that the future research could have a larger target audience, and then you can also conduct in different countries. Basically, these are based on our limitations, and then they can also increase the number of respondents. It could test other variables because our R square was around 0.26, which means there are other variables out there which also affect impulsive buying behavior. And future research could also dive deeper into the omni-channel factors, because for us, we only studied the online channel. So that would be all from our presentation. Thank you so much for your time and attention. So if you have any questions, Eugene and I will be happy to answer.
Nice presentation. I just want to know that have you done the behavior comparison based on the product category? Like for, let's say, for one product category, buying behavior was like this, and for second type of product category, behavior was different. So have you done such a type of comparison?
Okay, actually that was also part of our limitation because we focus mainly only on the fashion products, but that was also part of our recommendation for future research. So we'll be very happy to actually explore that as well. But as of now, we haven't done that yet for this research paper.
Okay, thank you.
Thank you for the question.
Thank you. Thank you so much for your presentation. Thank you, ma'am. Moving on to the next presentation. We have harnessing Microsoft Fabric for new analytics with Azure Bing Search API. Dear presenter, could you please start with your presentation?
Yes, ma'am. Hope I'm audible.
Yes, sir, you are audible.
Yeah, very good morning. My project title is Harnessing Microsoft Fabric for News Analytics with Azure Bing Search API. And my co-authors are Ganesh, Mamta, and Shreya and Fernandez. The content I'll be covering here is the problem statement, introduction, objectives, methodology, and results and discussions. And going further, the problem statement focuses on the vast and continuously growing volume of unstructured news data presents a challenge for organizations aiming to extract meaningful insights in real time. Traditional methods are inadequate for processing such data effectively. The solution is to leverage Microsoft Fabric to transform this large-scale unstructured news data into actionable insights. Enabling timely decision making is very much crucial in this trend identification and proactive strategies across various domains. Coming to the introduction, in today's fast-facing environment, staying informed about current events and news is an essential part of businesses, researchers, and other individuals. As we see in this digitization era, proliferation of online news sources has led to an overwhelming amount of data, making it difficult to extract valuable insights. The sheer volume of information requires advanced data analytics, which has been less spoken in the traditional analysis, to process and make sense of the data effectively. Here we are using Microsoft Fabric, which is a common platform and a powerful data processing and analysis capabilities, offers a solution to manage and analyze large-scale data. We're going to combine Bing API data with Microsoft Fabric, we can perform in-depth analysis of current affairs and emerging trends. This project aims to leverage the combined potential of both the Microsoft Fabric as well as Bing News API to generate an actionable insights. The results will help decision makers across various sectors to stay informed, anticipate shifts, and make informed data-driven decisions. Coming to the objectives, we're gonna develop a system using Microsoft Fabric to process and analyze large volumes of news data and implement news analytics using Microsoft API, that is Bing API, visualize it to form a data reporting in Power BI, provide a comprehensive dashboard to track insights. And the report will be enabled organizations to adapt proactive strategies by monitoring and analyzing news data in real time. Coming to the methodology, this is the system architecture. As I have already informed, we're going to use two components, that is Bing API and Microsoft Fabric. These both are the inbuilt features of Microsoft Azure. Bing API, let's start with the environment setup. First, the environment has to be set up for Bing API as well as Microsoft Fabric. We're going to create two resource group for one is for Bing API and the other one is for Microsoft Fabric. And then we need to configure like API integration with the database. Here we are using the one-leg database, which is a built-in feature for Microsoft Fabric. Then access permissions has to be provided. Then API keys for authentication. Bing API keys for authentication. The next is the data ingestion. Coming to the data ingestion, here we are using the data factory, that Azure data factory, which helps in designing a data orchestration of, which helps in designing a pipeline to orchestrate the data ingestion. The pipeline triggers to fetch data from Bing API and in a JSON format and store in a one-leg database of Microsoft Fabric. Here, the copying of JSON data to the database takes place at the data ingestion. And the next will be the data transformation. In the data transformation, here we are harnessing the Synapse data engineering tool, which is also a built-in component of Fabric. That's how the Fabric is so beautiful. It provides a common platform for different components here. Here we are using the data factory, which is a data engineering component of Synapse, and Synapse data science component, and as well as Power BI, which is an analytic component. So it provides a common platform which inclusions of all the three. So coming to the data transformation, here we are using Synapse data engineering, which has built-in PySpark notebook. We use PySpark script to transform the data to transform the unstructured raw data coming up from data factory, and it's organized and structured and stored in a tabular format. It's a delta table. Delta table is nothing but a default storage format they're using to store in a one-leg database. And coming to the sentiment analysis, the fifth one here, we are using the Synapse data science component for sentiment analysis. It has inbuilt machine learning models, which is a pre-trained for textual analysis. Here we are using text analyze pre-trained model for textual analysis. It picks up the words from the news article descriptions and performs and segregates whether it's a positive, neutral, or negative sentiment scores. And this transformed data after analysis is stored in DP as a latest table. And going further, the data reporting part. Here we're gonna use the transformed data with the sentiment scores is used to form an interactive dashboard in Power BI, which shows the sentiment percentages and published for stakeholders for decision making and further for decision making and further insights. Yeah, this is how the methodology, the data ingestion and data transformation, which I have already covered. And this is the sentiment analysis we perform, where we use textual news and extract sentiment from that. Microsoft Synapse data tools are employed for the analysis and resulting stored in appropriate data storage solutions. Data reporting part involves the Power BI to generate interactive dashboards, and the Reports and dashboards are presenting results to stakeholders in an easy to understand format. Yeah, this is the final dashboard how the Power BI gives to the business stakeholders. You can see the news has been segregated in the tabular format. It contains the column for title, category, whether it's a world news, whether it's an entertainment category, lifestyle, or science and technology, sports, and going further. And it also shows the provider, who has been published, like Axios, Billboard, Business Insider, and also consists of the URL for that news article and also the date of published. And you can also see that the rightmost corner, you can see the pie chart, which shows the sentiment score for that percentage. What percentage the news is neutral, what percentage is the negative, what percentage it's a positive news. And also it shows that the leftmost corner, you can see the date published and the sentiment. It's a slider button. Actually, we can filter out the date published and the sentiment accordingly here, whether it's a neutral, negative, and positive. And also we can see the bar chart with the news segregated, whether it's entertainment, lifestyle, or business, science, world, and politics. And this is how the final insights in the Power BI looks like. Coming to the results and discussions, the results demonstrate an effective system for handling news data. The Bing Search API ensures access to current articles, while Azure Data Factory manages data ingestion. Azure Fabric coordinates the data pipeline, and PySpark in Azure Synapse processes the structures, the data. Sentiment analysis using Azure Synapse Data Science provides insights into the emotional tone of news, which is then visualized in an interactive Power BI dashboard. This approach delivers valuable insights into public sentiment, improving decision making and enabling proactive responses to trends. Coming to the conclusion, the system effectively retrieves and processes the huge news data which is coming up in real time using Search API and Microsoft Fabric. Microsoft Fabric integrates and manages the data pipeline effectively. As I said, Microsoft Fabric provides a common platform and helps in orchestrating the data pipeline, which composes of three professional components, that is data engineering component, that is data factory, data science component, that is Synapse Data Science, and also the data analytics component, the Power BI. So it's from a common platform for entire thing. And coming to the data transformation, yeah, as I said, we use the PySpark and Azure Synapse Data Science. And going further, the insights are visualized through Power BI dashboard, highlighting key sentiment trends actually. These are the references which I've used for my work, for the project and all. Yeah, that's it. Thank you.
Nice
Any
presentation,
questions?
Abhishek. I would like to know that how much volume of data it can handle, and like, is it possible to handle the sarcasm given in news? Is it handling that?
Yes, ma'am. We can give the query parameters. It's a bit flexible. We can, in our experiment, we have faced the 100 news articles. We can also set the parameters, query parameters to 25 and 100 or any other things. And coming to the sarcasm part, we can work upon that. As of now, we have designed to handle only the sentiments, which gives the tones to the news, like a positive, neutral, and negative. So that thing can also be handled.
Okay, thank you, Abhishek.
Thank you. Thank you so much, everyone.
Thank you. Thank you so much for your presentation. Moving on to our next presentation. Have information systems in Indian dairy cooperatives, a case study of Sabar Dairy. Dear presenter, could you please start with your presentation? I repeat, information systems in Indian dairy cooperatives, a case dairy of Sabar Dairy. Okay. This is the first presenter. If he's here, you can start with your presentation. Breaking down barriers, investigating the advantages and challenges of Open RAN deployment in next generation wireless network. Dear presenter, could you please start with your presentation if you are available? Moving on to the next presenter, emotion recognition in Gujarati audio using feature extraction for machine learning models. Dear presenter, could you please start with your presentation if you're available in the meeting?
Hello, ma'am. Sorry to interrupt. By when we will be receiving the certificates actually?
I'll be intimidating everything towards the end. Yeah.
Sure,
You
ma'am.
just okay. Ma'am, we are open to your valuable remarks and feedback to all our presenters.
Thank you, Aarti. So it was actually nice learning for me as well. So different topics I could listen and I could understand the research they are working on. So I would like to say them very all the best for their research. And it was nice day. Thank you.
Thank you so much, ma'am.
Thank you, ma'am.
I would request everyone to please wait for a few minutes. As we have our three presenters absent, so I would request everyone to please stay connected till 9. Thank you. That brings us to the end of all our presentations. So, yeah, I would sincerely thank all our authors for their excellent presentations and contributions in this session and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, would thank you for the support during this third version of the conference and all the previous two versions as well. We would be very happy to have you all in the fourth version as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to Springer. So the publication would be live within 6 months. Kindly cooperate with the team of ISBM 2024. I also thank our session chair, Professor Geetanjali R. Shinde, ma'am, for chairing the session. A token of appreciation to our chair on behalf of Team ISBM 2024 and Global Knowledge Research Foundation and partners. Thank you so much, ma'am, for your valuable presence.
Thank you, Aarti.
I would kindly request everyone to switch on your camera so that we can have a quick snapshot of this virtual conference. I would request everyone to please switch on your camera. Thank you. Thank you so much, everyone. Stay safe and take care.
Thank you.
Thank you.
Thank you, ma'am.
Thank you.
Thank you.